Hey, fifth graders, it's Miss Richardson here. This week we are going to start off by talking about algebraic expressions. We started this last week. We're going to continue with it. These are our standards, and these are our learning targets. All right, so this is a list that you guys have all seen before. So these are words that you just basically have to memorize what they represent. You definitely need to know that the word sum in math, S-U-M, means you're going to be adding. All right, the word difference in math means you're subtracting. Multiplication, if I say, what is the product of 5 and 3? I'm asking you, what is 5 times 3? And if I say, what is the quotient of 20 and 5? I want you to divide 20 and 5. And the rest of the words, you probably know most of them already. I would say that these are 4 of the biggest ones that you definitely need to memorize. All right, so one thing you need to remember that order matters, especially when subtracting and dividing. So we talked last week about properties. So commutative property exists for addition and multiplication, but not subtraction and division, because I could rearrange 3 plus 8 and write 8 plus 3, I'm going to get the same answer, right? Same thing with multiplication. I can multiply 5 times 4, and if I turn those numbers around, I'm going to get the same answer. However, 10 minus 2 does not equal the same as 2 minus 10. 10 minus 2 is 8. 2 minus 10, I would get negative 8. You can't take a bigger number away from a smaller number and have anything left over. Same thing with division. If I divide, I don't know, 20 by 2, I'm not going to get the same as if I divide 2 by 20. I would get 1/10. Okie dokie. So be careful, especially when you're subtracting and dividing. If you get the wrong order, you could miss the problem. All right, so let's practice a couple of these, a little review. The quotient of 6 and x. Would I write that as 6 divided by x or x divided by 6? There's only one answer, and it is the first one, 6 divided by x. You have to write them in the order it's written in the word phrase. What about the difference of x and 10? The difference of x and 10. Would I write 10 minus x or x minus 10? There's only one answer, and it is the second one. If you wrote it in this order, you are not correct. That's actually wrong, okay? All right, so there are a couple of phrases that are always reverse order. All right, so whatever comes first, if you see a less than, you're going to take that number and you're going to throw it to the end of the expression. For example, if I say 5 less than the sum of 6 and r, since it says less than, I'm going to take this and I'm going to throw it to the end of the whole phrase. All right, so the sum of 6 and r, I start with that, the sum of 6 and r. And then 5 less than that, minus 5. So this is the only answer to this. It's the only correct answer, okay? Here's a more than. So I'm going to take what's in front of the more than, and I'm going to send it to the end of the phrase. So we're going to ignore it for a minute. The product of 2 and s is 2s, and then x more than that, plus x. Now, technically, since it's a plus, if I wrote x plus 2s, it's still technically correct, but we're to practice writing these in the exact right order. All right, another one is take away. So we're going to take away 2 from x. So let's say I said, what if I take away 2 from 10? You know the answer is 8. Well, in your head, you flipped the order that I said it. You said 10 minus 2. So the same thing. Take away 2, you're going to throw this whole thing at the end. And so we would actually start with x minus 2. Take 2 away from x. That's how it looks. All right, so I want you guys to pause the video and I want you to try to do these first 5 on your own, trying to get the order exactly right, and then come back and check your answer. All right, the first one, the difference of y and 5, the only correct answer is y minus 5. So since the y comes first, it must come first in the algebraic expression. 2 is added to the sum of 6 and w. So 2 is added to the sum of 6 and w. Well, that looks like 6 plus w. Okay. Now this is all adding. So if you rearranged any of these, it would technically still be correct. But like I said, we're practice writing these exactly right. All right, 4 times m, and then we see plus 3/4. So 4 times m is 4m plus 3/4. That's exactly what that looks like. All right, 4 times what? The sum of m and 3/4. So sum means this stays together. So the sum of m and 3/4, and then it's 4 times all of that, 4 times the quantity m plus 3/4. So these have the same words, but look how they're different. Okay, so make sure you notice why those differ. All right, we have x squared plus what? The quotient of 6 and y. So let's see what that looks like. What is the quotient of 6 and y? The quotient of 6 and y. So x squared plus the quotient of 6 and y, comma, means the last thing we're going to do is add 2. And it's okay. Every time you see a comma, you can group whatever's in front of it. You don't have to in this situation, but sometimes you do have to use parentheses like this one here. If you don't use parentheses, that's incorrect. All right, now the last 5, there's multiple answers, but I just want you guys to practice thinking of word phrases that would be appropriate for these expressions. So you think of some and then listen to what I say. All right, so number 6, you could say simply y minus 5. You could say the difference of y and 5. You could say 5 less than y, or you can say take away y from 5. No, that's not right. Take away 5 from y. Oh, I said that one wrong because take away is reverse order. All right, number 7, you could say 2 plus the difference of w and 1. You could say 2 plus 2 plus w minus 1. All right, number 8 is going to be similar to number 4 up here. So you would say 3 times the sum of n and 5. So, or you could say 3 times the quantity n plus 5, something like that. All right, number 9, you could say u less than 2. You could say take away u from 2. You could say the difference of 2 and u, or you can simply say 2 minus u. And then the last one, you could say 2 times the quantity of 5 plus w, comma, minus 4. Something like that. Okay? So like I said, there's multiple answers. So hopefully you got maybe some that I got right as well, or I said as well. All right, so a quick review. You guys looked at, how to determine how many terms you have, coefficients, constants, all that last week. But just a review, how do we separate terms? How do we know that these are 1, 2, 3, 4, 5 different terms? Well, terms are separated by plus and minus signs. So the first one is a term, and then it separates this one from 6. So we have 1, 2, let's circle our terms. We have one term here. We have a positive 6. Remember that sign belongs to that number or that term. We have minus 2x. We have positive 10, and we have positive 5x squared. So there's our 5 separate terms. And how are they separated? By plus and minus symbols. What are the coefficients? So remember, a coefficient is the number attached to the variable, not the variables. Last week, a lot of you typed, when I said, what are the coefficients? You would type like 5w or 5x. That's not right. It's just 5. So the coefficients are the numbers attached to the variables. So we have 5 It's not 2, it's minus 2 and another 5. We didn't have to write that 5 twice, but the two different coefficients are 5 and minus 2. And then a constant is a number not multiplied by a variable. So the constants are 6 and positive 10. And then what are like terms? Like terms have the same variables and exponents. The same variables and exponents. Alrighty, so let me clear off this. So let's see what our like terms are, because we're going to end up combining our like terms. So we have 5x. What is 5x like? Minus 2x. So 5x minus 2. It was 5 minus 2. 5 minus 2 is 3x. Okay, just subtracting. And then we have positive 6 plus 10. So 6 plus 10 is 16. And then this term is by itself. There's nothing to combine it with. It's not like these first two terms because it has a variable too, and these do not. But that must be part of our answer. So this is the final answer when we combine like terms. Now, these are all plus. If you wrote this in any different order, that's completely fine. It's still correct. Okay? All righty, guys. All right, so I want you guys to pause the video. I want you to practice combining like terms and then come back and check your answers. All right, on the first one, we have 2x plus 5x is 7x. We have positive 7 minus 1. 7 minus 1 is positive 6. Remember, you always have to have a sign here, and almost about 95%, 99% of signs in your grade level, 6th grade, is going to be positive, unless we're distributing, and that middle sign is a negative, okay? All right, so we have 5x squared is like minus 2x squared. Did I say 5? I meant 7x squared minus 2x squared is 5x squared. And then we have positive 3x, has to be part of our answer. And then we have 8 plus 10. 8 plus 10 is 18. There's our answer. All right, the next one, we'll start with our y's. We have 5 yo-yos minus 3 yo-yos. That's 2 yo-yos. And then we have 6x plus 2x. 6x plus 2x is 8x. And then this term is all by itself. It must be part of our answer. The next one, we have 4x plus 2x, which is 6x. And then plus 13 is part of our answer. And then this one down here, we have 5x plus 3x. So that's 8x. We have 4 yo-yos minus 4 yo-yos. If you had 4 yo-yos and I took them away from you, what would you be holding in your hand? Nothing. So we're not even going to write plus 0 y. You don't even need that because 0 times anything is 0, right? So our y's go away. And then we have positive 3 minus 3. What's positive 3 minus 3? Once again, nothing, right? So technically, our only answer is 8x. If you had typed plus 0y plus 0, I probably would have given you credit for it, but really you don't need to ever write zeros. All right, so what property is being demonstrated? Both of these show, what is it called? The distributive property, where we multiply 3 times 7 and we add that to 3 times 4 and we get 33. The reason distributive property is so important is because when you have a problem like this, when you have unlike terms in the parentheses, the only way you can simplify it is by using the distributive property. So you're going to distribute that 4. 4 times x is 4x, and 4 times 3 is positive 12. Whatever sign is between those two terms is the sign we use over here. Okay? All right, so I want you guys to try to use your distributive property and also make sure your whole expression is simplified. You're going to combine all like terms, so please pause the video and try that on your own and then come back and check your answers. All right, so we have 7 times x is 7x. And we're going to add that because that's our sign to 7 times 2 is 14. Number 2, we have 3x plus 15. And then we write our minus 2. And then we see, oh, these are like terms. 15 minus 2, we can combine those. So 15 minus 2 is positive 13. Positive 13. All right, on this one, we're distributing the 3 times a plus 3 times 4. Number 4, we're going to start with our 4, and then we're going to distribute plus 2x plus 4 minus 6. All right, let's see what our like terms are. 4 plus 4 is 8, and 8 minus 6 is 2. So we have 2 plus 2x. Or if we wrote it the other way, that's totally fine. And number 5, we have 5 times y. And this time we're using a minus because that's our sign here. 5 times 2 is 10. How'd you guys do? I hope you did well. All right, so another thing you're going to do is simplify by finding the perimeter of a shape. So if I told you, all right, guys, we have a rectangle, and I want to find the perimeter. And if this side is 10 and this side is 2, do you remember how to find the perimeter of a figure? You add all the sides together to find the perimeter. Well, this rectangle has 4 sides. Even if only 2 are listed, I know all rectangles have 4 sides. So if this side's 10, this one is 10. And if this side is 2, this one is also 2. So there's 2 different ways I can think of this. I can think, okay, I had a 10, but I'm going to double it. And then I had a 2, but I'm going to double it. So if I double 10, I get 20. And if I double 2, I get 4. So my final answer is 24. All right. A different way to think about it is just go ahead and write out all those side lengths and add them together that way. And either way, we get 24. Okay. So here we have a square. All the sides are the same length. So we have 4 sides that are 2x each. So if we distribute that 4 times 2x is 8x. Or I could just go around and count them up. I could say 2x plus 2x plus 2x plus 2x, 2, 4, 6, 8. I know my answer is still 8x. All right, so I want to challenge you guys to try to do these on your own, and then come back and watch my video and see what the answers are. All right, so number 1, what I would do, I have 2 sides that are n plus 6, right? And I'm going to add that to 2 sides that are 4n. So I'm going to distribute my 2. So 2 times n is 2n. 2 times 6 is 12. And then 2 times 4n is 8n. So when I combine like terms, I get 10n plus 12. Another thing I could have done is just start with this picture and just go around combining like terms. So I know I have 6 plus 6 is 12. And then I have 1n plus 4n, 5n, plus 1n is 6n, and 6n plus 4n is 10n. So same answer, right? All right, number 2, even though 2 sides are labeled, we know there's 4 sides. So once again, we can just go around this thing. I have 1n plus 1n is 2n, 2n plus 1n is 3n, and 3n plus 1n is 4n. And then I have a 2 plus 2. So 2 plus 2 is 4. Number 3, I'm going to add together my like terms. So 14a plus 7a plus 11b. My like terms are 14 and 7. 7, 8, 9, 10, 11. So that's 21a plus 11b. That's my answer. That should be a B. That's very messy. 21a plus 11b. All right, number 4, I have 1a, 1a, and 1a. So I know I have 3 a's, and then all together, my whole numbers, my constants equal 10. And number 5, I have 2x plus 1x plus 1x. 2 plus 1 plus 1 is 2x. And then I have 1 plus 1, and I get 2y. And that is my answer. How'd you guys do? I bet you did great. All right, so now you should have enough information in order to do the combining like terms. I can't remember what your first assignment was. Let me pause the video for just a second and I'll go look. Okay, yeah, so I looked at the Canvas course, and so these practice problems we did is enough for you guys to complete your first 2 assignments for the week, which is writing expressions for 12/6, December 6th, and equivalent expressions using the distributive property for December 7th. All right, so I will make you guys a different video for Thursday that will help you finish Friday's and next Monday's lesson. All right, guys. Y'all have a great day, and I will check on you guys later. Bye.